Something catastrophic is unfolding in the electric vehicle industry right now, and Wall Street is completely blind to it. Tesla, the company that promised to revolutionize transportation and lead America's electric future, has just discovered a fatal weakness in its supply chain. By the way, welcome to the Falling Value channel. Through our analysis, we will enhance your financial literacy skills. This vulnerability could not only bring down Tesla, but every single electric vehicle manufacturer in the United States. I'm not talking about lithium batteries or rare earth magnets. I'm talking about something much more basic, much more critical, and far more dangerous. Silver, the metal no one thinks about. The metal that is of absolute importance for every electric vehicle rolling off the production lines today. And China has just proven that they can cut off America's access to it whenever they wish. I am not a financial advisor. This is not financial advice, and I have no affiliation with anyone mentioned in this video. This is an educational analysis based entirely on publicly available information. Let us examine Tesla's hidden silver dependency. First, let me show you the figures that Tesla does not advertise in its earnings calls. Every single Tesla vehicle contains between 25 to 50 grams of silver. This equates to roughly 1 to 1.6 ounces per car. Now, I know what you are thinking. This does not seem like much. However, this is where the mathematics becomes absolutely devastating. In the year 2024, Tesla produced 1.77 million vehicles. In the first 3 quarters of 2025, they have already manufactured more than 1 million units. Calculate this with me. Based on a conservative estimate of 35 grams per vehicle, Tesla alone consumed approximately 43 to 88 million grams of silver last year. This represents 1.4 to 2.8 million troy ounces for just one company. But the detail that changes everything is this. This silver is not just sitting in the battery pack. It is woven into the entire electrical architecture of every vehicle Tesla produces. Exactly where does it go? Electrical contacts and connectors, circuit boards in the battery management system, power electronics and inverters, control modules, wiring harnesses, sensor arrays, and high-performance switches. In other words, every component where electrical efficiency determines whether your Tesla achieves a range of 300 miles or 250 miles. Regarding why silver cannot be substituted, it is because silver possesses the highest electrical conductivity of all metals on Earth. In an electric vehicle, where every 1-point increase in efficiency translates directly into driving range, and where range determines whether customers buy your car or your competitors, there is no substitute for silver. You cannot physically build a competitive electric vehicle without silver. Compare this to traditional cars. An internal combustion engine vehicle uses 15 to 28 grams of silver. A Tesla, on the other hand, uses up to 50 grams. This is nearly double the silver content. Now, scale this across the entire industry. Global electric vehicle sales reached 17 million units in 2025. The automotive sector is currently consuming approximately 90 to 94 million ounces of silver annually, and this figure is expected to rise every year. By the year 2027, electric vehicles will overtake internal combustion engines as the largest single source of automotive silver demand. By 2031, electric vehicles will account for 59% of all silver used in the automotive sector. The demand curve is exponential. However, here is the nightmare scenario. Tesla's entire production model, every factory it has built, and every supply contract it has signed rests on a single critical assumption. The assumption that silver will always be available at scale, at stable prices, and from reliable sources. That assumption has just been shattered. Let me tell you what they are not discussing on financial news networks. When most people think of silver production, they imagine mines in Mexico or Peru extracting ore from the ground. And yes, Mexico is the leading producer of mined silver, accounting for approximately 24% of global production. China and Peru each produce about 13%. However, extracting raw ore is only half of the equation. What truly matters is refining and processing. This is where China has established total dominance. China controls the processing infrastructure that transforms raw, silver-bearing ore into the refined metal that manufacturers can actually use. The critical detail that most analysts miss is this. Approximately 70 to 75% of the world's silver does not come from primary silver mines. It comes as a byproduct of lead, zinc, and copper mining. And China is the world's largest producer and refiner of these base metals. This means that even silver mined in Mexico, Peru, or Australia usually passes through Chinese smelting and refining infrastructure before reaching the market in a usable form. Consider the strategic implications. China does not need to own the silver mines. They control the processing bottleneck. This is the exact same playbook they implemented with rare earth elements. They do not mine all the rare earths in the world, but they control more than 90% of the processing capacity, which gives them total leverage over the entire supply chain. And, in the year 2025, they began to use this leverage as a weapon. The timeline is as follows. On April 4th, 2025, China imposed export controls on 7 heavy rare earth elements, including samarium, gadolinium, terbium, and dysprosium. These materials are critical for electric vehicle motors and electronics. Companies attempting to export these materials suddenly faced months-long delays, mountains of paperwork, and license denials for anything with potential military applications. In October 2025, China ramped things up. They expanded export controls to include medium rare earth processing technologies and introduced even stricter end-user verification requirements. European automakers began shutting down production lines. Prices for terbium and dysprosium surged 3 to 6 times in non-Chinese markets. The message was crystal clear. China can strangle supply chains whenever geopolitical interests require it. Now, following high-level negotiations between President Trump and Xi Jinping in South Korea, China agreed to suspend many of these restrictions. However, this suspension period expires in November 2026. This is a temporary situation, a geopolitical pause button. And every supply chain manager in America understands what this means. The threat has not disappeared, it is merely on hold. Let us examine Tesla's exposure to this Chinese supply chain bottleneck, because the figures are far worse than most investors realize. Tesla's Shanghai Gigafactory is not just an ordinary production facility, it is the most productive facility in Tesla's entire global network. Annual capacity exceeds 950,000 vehicles. As of December 2025, the Shanghai factory has cumulatively produced more than 4 million vehicles. It accounts for approximately 50% of Tesla's total global deliveries. In other words, 1 out of every 2 Teslas sold worldwide comes from a single factory in China. However, the dependency goes deeper. More than 95% of the components used in Shanghai-made Teslas come from approximately 400 Chinese suppliers. These are not just insignificant parts. They include battery cells from CATL, the world's largest battery manufacturer. CATL supplies the lithium iron phosphate cells that power standard range Model 3 and Model Y vehicles. CATL also provides critical cathode components to Tesla's Texas Gigafactory for the production of advanced 4,680 batteries. Approximately 40% of Tesla's global electric vehicle battery material suppliers are Chinese companies. Ganfeng Lithium for lithium products, Zhejiang Huayu Cobalt for cobalt materials, and Jiangsu Novare for inorganic compounds. These suppliers provide the integrated electrical systems containing the silver-intensive components we discussed. Connectors, circuit boards, power electronics, essentially everything that makes an electric vehicle actually function. While Wall Street is obsessed with Tesla's quarterly delivery numbers and Elon Musk's latest statements, a much more serious story is developing in the company's financial statements. Tesla's profit margins are collapsing. In the third quarter of 2025, the total gross margin fell to 18% compared to last year. Excluding regulatory credits, the automotive gross margin dropped to approximately 14.7 to 15.4%. The operating margin crashed to 5.8%, falling more than 500 basis points year over year. Third quarter net profit decreased by 37% compared to the previous year, falling to $1.4 billion. These are margins that look like traditional automakers, not the premium technology company Tesla has positioned itself as. The official explanation is price cuts. Tesla slashed prices throughout 2024 and 2025 to stimulate demand and compete with Chinese manufacturers like BYD. However, there is another factor that is not being discussed enough: cost sensitivity to raw materials. Batteries account for 30 to 40% of Tesla's production cost, and the metals in these batteries experience extreme price volatility. A jump of 30 to 50% in lithium or nickel prices means an additional cost of $2,000 to $5,000 per vehicle. In 2025, Tesla actually benefited from lithium prices that collapsed due to oversupply. This helped alleviate the margin pressure caused by aggressive price cuts. But what happens if supply tightens again? What if China restricts the export of critical processing capacity? Tesla gets squeezed from both sides. They cannot raise prices due to competition from BYD and others. They cannot absorb cost increases because margins are already suppressed. And they cannot easily change suppliers because the supply chain is optimized for specific sources. This is why the silver situation is so critical. Silver is not Tesla's largest metal cost, but it is a non-negotiable component with no effective substitute. Let me show you how catastrophically the United States is actually exposed regarding the critical metals needed for electric vehicles. According to the U.S. Geological Survey 2025 report, the United States is 100% net import, reliant for 12 to 15 critical minerals. It is more than 50% reliant for an additional 28 to 29 minerals. And for many of these materials, China is the leading or dominant import source. Specifically for silver, there are approximately 24 refineries in the U.S. reporting commercial-grade silver production. Local mine production in 2024 totaled approximately 1,100 metric tons, or 35.4 million troy ounces. However, here is the devastating reality. This is far from enough for domestic demand. The U.S. automotive sector alone is expected to consume 90 to 94 million ounces of silver annually by 2031. When you add solar panels, electronics, AI data centers, and other industrial applications, you face a massive structural supply deficit. Now, let us examine what is actually happening in the physical silver market, because this is where supply chain vulnerabilities collide with market fundamentals to create a perfect storm. According to the latest data from the Silver Institute, as of November 2025, the global silver market is heading toward its fifth consecutive annual deficit. The projected deficit for 2025 is approximately 95 million ounces. This means 95 million ounces more silver was consumed than produced through mining and recycling. The cumulative deficit from 2021 to 2025 totals approximately 820 million ounces. To put this in perspective, 820 million ounces of silver vanished from above-ground stocks in 5 years. This is roughly equivalent to a full year of global mine production. Where did it go? Into non-recyclable solar panels, electronic devices buried in landfills, and industrial applications where silver is effectively consumed and cannot be recovered. Supply-side figures tell a concerning story. Total mined silver production in 2025 was approximately 835 million ounces. This is essentially stagnant compared to recent years. Mine production has actually fallen 7% since 2016. Despite the significant rise in silver prices, new mine production is not coming online fast enough to close the gap. Demand-side figures reveal the structural problem. Total global demand for 2025 is projected at 1.2 billion ounces. Industrial demand accounts for approximately 59% of total demand, or 665 million ounces. The solar energy sector alone consumes 230 to 260 million ounces. The automotive sector, driven by EV production, uses 90 to 94 million ounces annually. The math is simple. Demand exceeds supply by approximately 100 million ounces every year. Now, what makes this crisis fundamentally different from other commodity shortages is this. Remember, 70 to 75% of silver comes as a byproduct of lead, zinc, and copper mining. This means that silver supply does not respond to price signals like primary commodities. When copper demand drops, silver supply also falls, even if silver prices are soaring. Production depends on entirely different market dynamics. This creates a structural supply rigidity that cannot quickly adapt to rising industrial demand. Throughout 2025, silver prices climbed to multi-year highs and briefly touched $64 per ounce in mid-December. Many analysts predict that based purely on supply-demand fundamentals, silver will reach $100 by late 2026 or 2027, and that is the situation before accounting for any geopolitical disruptions. So let us connect all these threads and talk about what this really means for investors, Tesla shareholders, and anyone betting on the future of America's electric vehicles. Tesla cannot find silver, not because silver does not exist, but because Tesla cannot guarantee secure, uninterrupted access to the refined silver and critical materials needed to maintain its ambitious production targets. China's export controls, although temporarily suspended until November 2026, have exposed a fundamental vulnerability in the entire U.S. electric vehicle production ecosystem. What we are witnessing is the collision of three unstoppable forces. First, the global energy transition is creating unprecedented industrial demand for silver, rare earth elements, and dozens of other critical materials. Second, the supply chains for these materials pass directly through China, which has clearly shown its willingness to weaponize them as geopolitical leverage. Third, the United States has almost zero ability to change these supply chains in the short to medium term. Tesla's risk reduction efforts, the attempt to remove Chinese components from vehicles produced in American factories, can be completed in 2027 at the earliest. Meanwhile, the physical silver market is already running an annual deficit of 95 million ounces. Electric vehicle production is scaling faster than the growth in silver supply, and China's temporary suspension of export controls expires in less than 12 months, in November 2026. For investors, there are several critical takeaways you must understand. First, physical silver demand from industrial applications is structural and non-negotiable. Unlike investment demand, which can evaporate during bear markets, industrial users need silver to manufacture products. Second, companies with heavy exposure to Chinese supply chains, particularly in electric vehicles and electronics, face significant execution risk that stock analysts systematically underprice. Third, strategic metals like silver, copper, and rare earth elements are transforming from commodities into geopolitical assets. China's export restrictions did not just threaten Tesla, they revealed that American high-tech manufacturing, especially electric vehicles, is built on a supply chain foundation controlled by a strategic rival. This is not a sustainable position, it is not a secure position, and is about to force a complete restructuring of global production and supply chains. The question facing investors and policymakers is not whether this crisis will unfold, but how severe it will become before alternative supply chains can be built. And while this timeline currently stretches years into the future, the deficits are happening today. Geopolitical tensions are rising today, and the clock is ticking toward November 2026, when China's temporary export control suspension will be resolved. If you found this analysis valuable, continue following the stories that truly matter for your financial future. We addressed the geopolitical risks ignored by Wall Street, the supply chain vulnerabilities not seen in earnings reports, and the structural forces that determine which companies will survive in the next decade. Don't forget to subscribe and turn on notifications so you don't miss the content.